Thank you. So I work on various forms of abuse at Facebook and previously at LinkedIn. But I'm going to tell you a little secret, which is that sometimes I wish I worked on ads. Because from my point of view as a security person, I see ads shown on the internet like these ones here. And I think, oh, these, it's pretty easy to measure what's going on. You show ads, they get eyeballs, people click on them, then advertisers give you money. And that's dollars, that's the impact. So if I want to figure out what to work on, how to improve ad ranking, I look for the place to increase the dollars the most. And if I want to know whether that worked, I look at my revenue statement and say, did the dollars go up? Now my friends in ads tell me it's actually a little more complicated than that because there's stuff like user experience, but from my perch in security, it seems the grass is greener. But I don't work on ads. I work on fighting abuse, and these are just some of the things that we have to tackle at Facebook, and I'm sure many of you here also have to deal with. So things, from account access issues to click fraud, scraping, identity theft, and so on. And you have all these different things, and the question is how we figure out which one to work on, right? How should we prioritize these? And furthermore, once we make that decision and decide to work on something, then how do we know whether we're doing well? How do we measure the impact? So just as some examples, here's some examples of things that we look at Facebook. So adult imagery is something that we're trying to, clamp down on. We've got your traditional merchandise spam, and of course phishing and other forms of scams and bad content. So we really want to know, what's going on out there. But it turns out that measuring abuse is difficult. This is actually a very complex problem, and I'll touch on a number of different fields that we've drawn inspiration from in trying to deal with this. So one issue is that in my hypothetical ads example, everything was measured in dollars. In abuse, everything is in a different unit. I don't know how much a spam post is worth versus an account compromised versus an identity theft. Furthermore, we don't necessarily know what's out there, right? Some attacks take us by surprise. The adversary is always trying to get around our defenses, so we can't use standard machine learning techniques because those assume that your data is kind of unchanging. Most things on your site are good, so you have the kind of needle in a haystack problem, especially as you get to some of the more sort of kind of high impact, low prevalence categories. And finally, there's this problem of what is ground truth? What is bad anyway? And I have a picture here of former Supreme Court Justice Potter Stewart, who in a famous case on pornography said, "I don't know what it is, but I know it when I see it." And we want to avoid falling into that trap. We don't want everyone who's kind of in charge of deciding to know it when they see it. We want some kind of standard for ground truth of what is allowed and what's not. So we're going to kind of take you through kind of the process of how we build up measurement. And it starts in what I call the dark ages, where basically your prioritization function is who can yell the loudest. And so, that'll if your CEO is telling you to work on something, you're going to work on it. And, if some engineer finds a little problem, might not get as high a priority. And the impact is typically measured in how much stuff did we block. And I'll say in a minute why this is not a great metric, but basically we're kind of blind here. So kind of the difference between the Dark Ages and the Renaissance in history was kind of the advent of science. So if we want to apply science to our problem, we start to measure stuff. So for prioritization, we want to do something like, for each problem, figure out how much of it there is, what's the volume, and classify the different problems according to their harm level. So in this example, maybe spam is yellow, account takeover is orange, and identity theft is the worst one. That's a level red. And we don't have necessarily a scientific way to assign numerical values to these harm levels, but at least we can qualitatively bucket them and estimate the trade-offs. And then to figure out your priorities, you multiply volume times harm, and that should give you some kind of number that will allow you to at least rank the problems in order of importance, and then you can go through and assign resources. So once you work on something, how do you figure out what to do? And what I would argue here is that the amount of stuff that you block is not what matters. It's the amount of stuff you don't block. Right? Because the amount of stuff you block is what people aren't seeing, and the stuff you don't block is what's actually affecting your users, your false positives and your false negatives. And you can see these may be related, maybe not. At the beginning of this graph, you can see kind of the orange jumps up and the blue goes down, so maybe we started blocking a bunch of stuff that we were previously not blocking, sorry. But towards the end, you see the blue is fairly constant, and the orange is going down. Maybe that means the attacker gave up. And so the orange going down is a good thing in this case, because it's one less thing to worry about. So to do both of these things, we need some kind of measurement. So in addition to avoiding the prioritization function of yelling, measurement allows you to track your progress over time and figure out where you're going backwards. If you get enough quality measurement, you can train machine learning models using this data. If you have enough coverage, you can do deep dives into what are we missing, where are we going wrong, what are the trends, what is this example, what are the examples. And if you have if your measurement is delayed, you can at least take down some stuff retroactively, provided that you don't mess up your measurement, and I'll go into that in a little bit. So basically, in this transition from the Dark Ages to the Renaissance, from kind of yelling and guessing to using science, we need a piece of technology to enable this transition. And for the cultural Renaissance in the 1500s or so, this piece of technology was the printing press. It allowed knowledge to be transferred broadly to many people. And for measuring abuse, this piece of technology is labeling. So it's being able to identify which things are bad, or look at all your content and decide which is good and which is bad. So now I want to talk about, dive into labeling and talk about how we actually label abuse. And the first approach, which it will be the one that I led with in the Dark Ages, was just count what you blocked. If you blocked it, it's bad, right? Even ignoring false positives, right? Maybe I blocked it and it's a bunch of false positives, so that doesn't count. Even assuming these are true positives, having a spike in this graph doesn't tell me anything. I don't know whether I should, ring the alarm, call up my, reserve incident responders and deal with this, or if this is just business as usual and there was a new attack, the system blocked it, I can go on. Without knowing what we didn't block, this is impossible. The other problem is, so that's one problem. Another problem is that looking at the past means you can't find new attacks. You only see what you've already blocked. And this is really a bad idea if you're trying to train machine learning models, because it creates feedback loops that can really throw things out of whack. So the next approach is to have your users do the labeling. Right? So this is a standard feature in many large-scale products. On Facebook, if there's a post, you click the dots. There's a choice to give feedback. And then within the feedback, you can say this is spam, harassment, violence, etc. And this gets you a lot of data, right? People like to report stuff. I mean, you probably all click spam on your email sometime, which is another similar reporting flow. And this goes good. This can show as a directional measure, right? If the number of reports doubles, probably something is going on, or maybe you launched a new product, but let's leave that aside. And reports can also surface things that the users care about that maybe your systems are missing, right? They close some of your blind spots. However, user reporting is wildly inconsistent. So in some previous research I've done, we found that for a certain category of reporting fake accounts on LinkedIn, the precision of reporters was something like 35%. Our reporting flows on Facebook, we also see poor precision according to our definitions. And the reason for that is our definitions are not the user's definitions, right? If you click spam on your email, typically it's just something you didn't want to see. Some promotion, maybe even a receipt, someone else signed you up for a service accidentally. And it's not necessarily spam as in defined by the policy as something that needs to be taken down from the service. In addition, reports can also be gamed. So suppose that I put in a policy that said, okay, any piece of content that gets reported 10 times gets taken down. Well then, certain unethical parties might decide, oh, did my competitor's posting, I'm going to get all my friends to report them as spam, and get their content taken down. So there's an adversarial aspect here, which means you can't always rely on reporting data. An approach that works much better and is really considered the gold standard within Facebook is human labeling. Get some experts to decide. And I guess this is the problem here is solving the I know it when I see it problem, right? So getting everybody to agree on what is the actual policy. So the way we do this is to create some kind of rubric. So have the experts go through and create a systematic rubric of things to look at and decisions to make that can allow you to assess whether a content or account or activity is legitimate or malicious. Then sample out of all your activity and send it to your trained labelers who can apply the rubric and get you measurement. Now, there's the problem that most things on your site are good, so this category imbalance that I talked about earlier. And so if say, 99% of things are good and I send random samples to labelers, they might not even notice when the one bad thing out of 100 shows up. This phenomenon of labeler fatigue has been well documented. And you also get large error bars if you're sending very few samples. So we solve this using stratified sampling. So we can use heuristics or some other classifiers to oversample suspicious activity, and this will address problems of labeler fatigue and also get you improved statistical estimates. And so this approach is deployed at Facebook on a number of problems, some of which are reported in our transparency report. And so we can define rubrics and measure these types of issues. Then we can do the analysis and get nice plots of over time, how is it changing, what are the error bars, and then based on this, we can look into trends. And you can say, why did it spike? Why did spam consumption spike on day 6? Or what is the examples that are driving this? And we can actually do similar. These are for false negatives, like bad things that show up. You can do the same thing for false positives. Real users that you blocked, or benign users that you blocked. But this doesn't work for everything. So you need standardized rubrics, you need infrastructure to handle all these content queuings and farming things out to labelers. And if I have a fake like on Facebook, or I guess a like on Facebook, and I want to figure out whether it's fake, I can't necessarily send that to a reviewer and say, here's a like, tell me whether it was malicious, right? It's easier to do with phishing, right? You look at the text, you look at the URL, etc. So the human labeling doesn't work for all problems. So what we've done is use some automated labeling. So the key idea, kind of from a technical point of view, is use some kind of clustering to group things together. Compute cluster level statistics to say, like, okay, here's some properties of this cluster, or maybe embed this cluster in some vector space as a point, and then do anomaly detection to find the outliers, and these tend to be the examples that are scripted. For example, if I have a cluster of, if I have one user who's doing a bunch of likes but hasn't sent any friend requests, maybe that's just what that user chose to do. But if I have thousands of users who all are liking and none of them are making any friend requests, then that's highly suspicious. That would be considered an anomaly that we could use in our labeling. So the automated detection is deployed on a number of problems at Facebook and used to track internal direction, set goals, and prioritize. So I just want to go back and compare all these different approaches. So I talked about 4 different approaches. And these are some dimensions that we care about when building a measurement system. So we want coverage, right? We want to capture all the false negatives. We want to be forward-looking, right? We're able to take action based on this rather than just look at the past. We want to avoid feedback loops so that when we act on it, we don't ruin our measurement. We want to be resistant to adversarial manipulation, right? We don't want the adversary to be able to game our measurement, because then we can't tell whether they actually went away or they just avoided our measurement. We want to be able to use this to inform detection, be able to look at examples, take deep dives, and we want to scale it to new problems, right? So if I build up a measurement system for spam, I want to be able to scale it also to fake likes, for example. So counting blocks really doesn't satisfy any of these, except, of course, it's easy to scale because you can count pretty much anything. User reporting, as we saw, is biased and can be manipulated, but is independent from your measurement, right? Because it's from our users. It can scale the back end will scale, but you need to do UI work for every new problem you need to put reporting on. And depending on the scale you can get and the precision, you may be able to use it to inform detection. Human labeling we have better luck with. And really the problem here is whether or not you can get enough samples to know that you have a representative view of all the abuse that's going on the platform. And the real drawback is in scaling, in that if I want to spin up a new set of human labelers, I have to do it all over again. There's no way to scale it anything else than make a new rubric, train up a bunch more people. Automated labeling checks a different set of boxes. So it may not capture all false negatives depending on the algorithm you use. And also depending on the signals you use, it may or may not be resistant to adversarial manipulation. But it does scale, and it does avoid feedback loops. And kind of the key takeaway here is that the successful approaches amplify expert opinion, right? So the user reporting is kind of the opinion of non-experts. And human labeling takes some experts, they write a rubric and scale that out to labelers. Automated labeling, we take some experts, they tune an anomaly detection system, and we can scale that out to all the different problems. But labeling is actually only the first step. Right? So we have labeling, and we want to turn that into measurement somehow. And here's where we run into something called Goodhart's law. So Charles Goodhart is a professor, was a professor at the London School of Economics. And he coined the observation that when a measure becomes a target, it ceases to be a good measure. So let me give an example. This is kind of a hypothetical example. Suppose that for my metric, I decide that there's some product, and if a user posts content more than 100 times an hour, they're not using the product correctly and they're bad. So I can just count how many people post more than 100 times an hour. And then I'm like, aha, I want to solve the problem. I launch a rate limit of 100 posts per hour. And my metric went to 0. I solved the problem, done, go home. So obviously that's not the case, but this is kind of an extreme example to illustrate what can go wrong when you enforce on your metric. Kind of taking a little bit higher level, this is not exactly a mathematical proof, but an illustration of kind of a little more abstractly what's going wrong. So we can think of like the absolute ground truth as some vector in a vector space. Like here's the actual state of the world known only to God, for example. And we mortal humans have to create some metric, and this is some dimension on which the ground truth is projected. And then there's an orthogonal dimension that's the unmeasurable part, kind of by definition. So basically the ground truth is the vector sum of the part we can measure and the part we can't measure. So what happens when we go on the metric and try to move it down? Well, so if we're successful, the metric dimension moves down. But the unmeasurable dimension maybe moved up, maybe moved down, maybe did nothing. We really have no control over it. But basically, if we were successful at moving the metric down, a larger component of the ground truth is now in the unmeasurable part. So we know less about the problem than we did before. And so the corollary that kind of I'd like to introduce here is what I call the abuse uncertainty principle, which is if you have a signal, you can use it for measurement or enforcement, but not both. Because if you use it for both, then you essentially don't know what has happened. And so applying the uncertainty principle at Facebook, if we take any signal, and we have to have some kind of principles as to whether we should use it for measurement or enforcement. And the principle that we use is if it's something that's sort of client-controlled or easily changed and doesn't actually solve the problem, to change it, then we use that for measurement. So for example, if you were we look at network properties or perhaps properties of the request or even user-generated content. And for enforcement, we use things that maybe they're easy to figure out, maybe they're not, but even if you figure them out, we've changed your behavior, we made it more difficult to carry out the abuse. So the rate limiting falls into that category. It's easy to stay below the rate limit, but at least once you've imposed the rate limit, you've moved some part towards solving the problem. And I want to note on user-generated content, so certainly for some categories you want image recognition, you want to say like this is a bad, this type of content is not allowed. But for kind of generic abusive behavior, compromise or fake accounts, you don't necessarily want to use user-generated content because it's adversarially controlled. And we've actually seen users obfuscating their spammy posts to the point where it almost looked like a CAPTCHA that we were going to have to solve to do the detection. So we don't want to do that. So other things that we do, so iterate constantly, right? So basically, you build V1 of your metric, you work on enforcement, driving it down, and while you're doing that, you build V2. And that catches some of this unmeasurable part that, and kind of this is a stack instead of the vector sum, but it's the same thing, right? So V2 has a new measurement that cuts into some of the unmeasurable part of V1. We drive that down while building V3 and so on. We also want to use, similarly, we want to use the metrics as directional rather than as absolute truth, right? I know there's a part that's not measurable, so I'm not going to report externally that, if I can't be very precise, that, so-and-so, such and such problem has exactly this number of examples on Facebook. and even internally, I wouldn't want to make that claim if I knew that there was some part of the problem that we were missing. And then you also have to validate the measurement, right? Measure the measurement. One way to do this is through user reporting, if you can properly clean it. Another way, we've done some work on this on Instagram side. We can actually look at the black market and buy traffic, buy illegitimate traffic. We've have a research paper on buying like fake likes and comments, and use this to see if our measurement is catching what's going on. So due to this work, which is building on the work of many dozens, if not hundreds of people within Facebook, I don't wish I worked on ads anymore. So I know how to use labeling to build measurement. I know how to use measurement to prioritize my work and determine the impact of what I do. There's still this problem, though, that everything is in different units. And I want to leave this kind of as a challenge, which is to build some kind of universal adapter that will get me, that will allow me to compare fake accounts and phishing and spam and identity theft and all these things, as well as to compare false negatives and false positives so I can decide which one I need to work on. So just leave you with a few questions. So one is, how do we obtain a truly reliable signal from user reporting? Right? We know we have multiple examples of users being very imprecise. And I talked about reporting, human labeling, automated labeling. Is there some kind of unified system that can combine all these and get us even closer to our goal? Thank you.